Okay, so I'm going to put this in the video what I just told you guys, that I'm reminding you that I am going to be out next week, and the home page is where you're going to go to find your notes videos to watch. Answer keys are all posted. Be extra careful that you're showing work for every problem. I'm going to be very strict about showing work for every problem in order to receive credit, because I do have the answer keys posted here. This link and this link are notes videos. This link is some sample problems worked out for that probably 11-2 even, if I had to guess. So that is a resource if you were confused on the problems from 11-2. All right, so we're going to go ahead and get started on 11-1, simplifying rational expressions. Does anybody know what the word rational means? Remember what rational means? And what's the root word for rational? You guys know what root words are? What's the root word for equation? Equal, yeah. The root word for rational is ratio. If you saw earbuds, AirPods, earbuds, or headphones, I'm going to take those out. Yeah, so the root word here is ratio. Well, really what we're doing is we're simplifying fraction expressions that are fractions, but they're going to have variables in the numerator and the denominator. So if you simplify fractions that have variables in the numerator and the denominator, we first start by factoring the numerator. And next, we factor the denominator. And you guys have done this before. I used the example in first period. Do you guys know how to simplify this fraction? Simplify this rational expression? Well, if we follow these directions, so when we simplify this normally, we look at what factor they have in common. What factor do 20 and 25 have in common? 5, right? So, but if we wanted to use this strategy, we could factor the numerator, 5 times 4. We could factor the denominator, 5 times 5. Does that part make sense? Anything in the numerator and denominator are identical. 5 divided by 5 just simplifies to 1, right? So this fraction was simplified to 4/5. For these expressions, we're going to have variables. Sometimes we're going to have variables in the numerator and the denominator. If we have variables in the numerator and the denominator, we're not going to cancel right away. What do we know about, what does this expression equal? 0 divided by 4. What's that equal? 0. What about 4 divided by 0? Using your calculator, what do you get? Not 0, you get an error. So this is an undefined, they call that an undefined answer. There is not a rational value set. My board is not working well. Undefined. We do not work with undefined answers. So when we're simplifying these fractions that have variables in the denominator, we're going to use a strategy like when we solve quadratic equations. We set those factors equal to 0 and solve to find the x values, right? Here, we're going to be setting the factors of the denominator equal to 0 to determine what numbers cannot go in there. So I'm going to give you an example. So let's say 2x over all right, this is a rational expression, an algebraic expression, a fraction. If we factor the numerator, we're going to have the same numerator. There's nothing to factor out of that. That's already factored. That's 2 times x, right? If we factor the denominator, what do these two terms have in common? 0. What is 0 minus times 5? 0. And there would be a 0 in the denominator then, right? So what we're saying is we can simplify these expressions, but when we simplify them, before we simplify them, we have to say which values you could not plug in to these expressions because they would make the denominator 0. So we call these excluded values. So what we're going to do, you guys have this written down somewhere? Okay. We're going to find and state, so we're going to do a little bit of work after we factor, find and state the excluded values by setting any factor in the denominator with the variable equal to 0 and solving. And I'm going to show you what all that means. Remember, factors are numbers that are being multiplied by one another. Okay, so if we do that here, only the denominator, not the numerator, because the numerator can be 0. Right? We already talked about that. 0 divided by 4 is 0, so that's a perfectly acceptable answer. But we can't have a 0 in the denominator, so we're looking, there's two factors here. We factored this into 5 times x minus 1. We only need to set the factors that have a variable in them equal to 0. So this is the factor, x minus 1, that has a variable in it, and we set that equal to 0, and we solve that one-step equation. So this is actually, we need to make clear, this is our excluded value. We're not solving an equation. You can't solve expressions. We only solve equations those that have an equal sign in them. We're not solving these. We're simplifying them, but we're also have to say, once we simplify this, you won't be able to see the value that would have made that expression, the denominator 0 anymore. So here the excluded value would be positive 1. So I would give my final answer, because I can't factor anything out of top and bottom. This would actually be my final answer, but I'm going to say, let's have a little semicolon here, I'm going to say x is not equal to 1. So we're saying you can plug, this is the simplified version of this expression. Well, actually, this is the simplified version, but we're going to write it as in factor form for now. But we had to factor the bottom so we know what the excluded values are. So that's one way to do it. That's what we're going to do. And last but not least, then we would cancel, like we canceled here, any factors that are common. This example I gave, you can't cancel any. Wasn't my best example. Wasn't my worst example I've ever given, but definitely not my best either. So the next thing we're going to do is just a bunch of examples. So this whole lesson, you have to be able to factor. So I'm going to give you a real quick review on factoring as we go. But we worked with factoring for a couple months now. So we tested, we had to factor for several tests. So I'm going to review the factoring just really quickly as we go. That part is not the new part. So the directions stay here. So let's go ahead and write these directions. Simplify each expression. State any excluded values. On all your problems today, you're going to state the excluded values. After we get out of this section, if they don't ask you to state the excluded values, you don't have to. So this section will state excluded values for everything, whether they say to or not. Let me put that in there. 26 spot. Okay. So you'll see the first 7 problems in your homework have those same directions. So that first example, go ahead and write that first example, 3n minus 15 divided by 12. I'll put them over here so they have a little bit more room. Alright, so first example, 3 times n minus 15 divided by 12. So we follow our directions. We're going to factor the numerator. What is the common factor in these two terms in this numerator? 3. So 3 times n gives me 3n, right? 3 times n is 3n minus, there's a minus there, 3 times 5 will give me 15, right? So 15 divided by 3 is 5. That's another way to think about that. So I have factored the numerator. The next step in our notes says to factor the denominator. Remember, the denominator is the bottom, D for down, downstairs. We're not going to factor the 12 because we can do that in our head. It's just a regular fraction here, right? So we did step number 1, step number 2. We're not going to factor that constant. If there was something else we could factor, we would. For the constants, we're going to leave them like that. Our next step says that any factors in the denominator that have a variable equals 0. But we don't have any variables in the denominator, right? So then we go ahead and cancel. So we have no excluded values. If there's not a variable in the denominator, there are no excluded values. But we can simplify this because 3 is a factor in the numerator, and 3 is also a factor of 12. So 3 comes out of 3 once, 3 comes out of 12 4 times. So this fraction simplifies to n minus 5 divided by 4 with no excluded values because there was no variable in the denominator. So far, so good? All right, so we're going to write the next example. So for the next example, we're still going to follow our steps. This is factor the numerator, but really this is already factored. This is 12 times c to the 8th power, right? The denominator, it says 36 times t to the 6th power. It's really already factored. So the next thing we're going to do is we're going to find our excluded values. So the denominator is the factor in the denominator, t to the 6th. And let's not do it that way because we've never done that as a root of 6, but let's factor all the t's. 1, 2, 3, 4. You guys don't have to do this. Once I tell you how to do it, you can do. I'll tell you. The t is not going to be able to equal to 0. 1, 2, 3, 4, 5, 6. So just to illustrate here, why if we said each of these factors equal to 0, well, they're the same factor, right? So we really only have to set one of the t's equal to 0. Does that make sense? Now, does that make sense? If there were different factors, we set them all equal to 0. But if the factors are all the same, the excluded value for this expression is 0, right? So this would be the excluded. This is how we find the excluded value. But I will tell you, if the factor is a variable to any exponent, t to the 2nd, t to the 4th, t to the 10th, it's just the variable in the denominator can't be 0, okay? So now we are going to simplify. 12 and 36 have a common factor of what? Sorry? 12, yes. 12 comes out of 12 once. 12 comes out of 36 3 times. Right? Do you guys remember how to simplify or how to divide like bases? T to the 8th power divided by t to the 6th power? Subtract their exponents, right? So that's going to be t to the 8th minus 6 would be t to the 2nd power. 1 times t to the 2nd is t to the 2nd. And now we have 3 left in the bottom. We've already done that. So that is your final answer. But your excluded value, t, cannot be equal to 0. And you don't have to write the excluded part. You can just say t is not equal to 0. So your final answer is both parts of this. Any questions? All right. The next example, y plus 2 divided by y squared minus 4. Factor the numerator and factor the denominator. Do you know how to factor the numerator and factor the denominator? Feel free to go ahead and do that. Give you a hint though. The numerator can't be factored, right? Y plus 2, there's nothing going to come out of those terms. There's no way to factor a binomial that's an addition plus a constant unless they have a common factor in each term. So y plus 2 is the only factor of the numerator. Can anybody tell me what the factors of the denominator are? Give you a hint. Perfect square minus a perfect square. That denominator is a difference of squares. That's one of our special products. Does anybody remember how to factor it? Just is the one binomial that will factor into two binomials. If it's a perfect square minus a perfect square, we know there's two binomials. We know one's going to be plus, we know one's going to be minus. Take the square root of the first term and put it in both first spots. Take the square root of that absolute value of that one, square root of 4 is 2. So now we have factored this expression. So these have parentheses around them because there's two factors here. We could put a parentheses around that and it looks more like this factor, but these would be the same factor, right? These are identical expressions. Remember, we're not talking about terms, right? I can't simplify a y and a y here, or a y and a y here. Factor, this will be 1 times 1 plus 2 if you want to put the numerator in terms of factors. There's two factors in the denominator. The sum of y and 2, so this entire expression is a factor. So we cannot cancel out parts of that factor. Does that make sense, Jeremiah? That makes sense, Stephen? Okay. We know we're going to be able to cancel those, but we don't want to cancel those yet. We want to find our excluded values first. So to find our excluded values, we only look at the denominator, and we set the factors of the denominator equal to 0 and solve. So the one factor is 1 plus 2. The other factor is y minus 2. We set them equal to 0 and solve those one-step equations. So we cannot plug in -2 because -2 plus +2 is 0. 0 times anything would be 0. That would make our denominator 0. If we plug in +2 on both spots in the bottom, this factor would be 2 minus 2, which is 0, right? So these are going to be our excluded values that we're going to get in our final answer. But first, we do our last step, which is simplify the factors in the numerator and denominator. So y plus 2 and y plus 2, anything divided by itself is 1, right? So that's 1. So what I have left up here, 1 in the numerator. The only thing left in the denominator is y minus 2. And I'm going to give my excluded values. Y cannot be, so it's not equal to -2 or 2. So that is the final answer. Any questions? Go ahead and write the example for 15a minus 50 divided by 10a plus 35. I would think after a little bit of a reminder, you guys should be able to factor the numerator and denominator here. So find a common factor in the numerator and factor that numerator. Find a common factor in each term in the denominator and factor that denominator. I'm going to give you a head start, and I'm going to do that part pretty quickly because we have about 20 minutes left, and we've got some more examples to get through. I'm going to factor the numerator. Factor the numerator. What if come out of both terms are good? Before we have the numerator factored, what will come out of both terms in the numerator? What will come out of both terms in the denominator? Will come out of both terms in the numerator. So what would be in that blank there then, Lee? What's the second factor going to be? If 5 is a greatest common factor here, what's going to be in the parentheses? Is that all? Minus 10. Good. 5 times 3a is 15a, minus 5 times 10 is 50. What's the greatest common factor in the denominator? Also 5. Yep, 2a what? Okay. We could technically go ahead and cancel here and find our excluded factors, but we don't want to do that because sometimes that doesn't work here. We have two factors. This factor is going to cancel. We all see the 5 and the 5 here, right? But well, like we did here, we didn't want to cancel yet because we defined excluded values. So we're always going to factor the numerator, factor the denominator, find your excluded values, then cancel. Okay? So that's what we're going to do here. Looking at the denominator for our excluded values, any factor that has a variable. So 5 doesn't have a variable. That factor doesn't have a variable, we can ignore it. We only need the one that has a variable. 2a plus 7, we set it equal to 0 to solve this two-step equation. We undo the addition first by subtracting. We undo the multiplication here by dividing. And now we know that our excluded value is negative 7/2. We have to state that in our final answer. Last step is to cancel any common factors in the numerator and denominator. So our final answer is going to be 3a minus 10 divided by 2a plus 7. That looks like a space or something there. But we're going to state that a cannot be equal to negative 7/2. You don't state the excluded values, you've only done half of what they asked you to do here. Any questions? Let's look at this next example. M cubed plus 9m divided by 6m cubed minus 3m. Would you write that example in your notes? Factor the numerator, factor the denominator. Anybody know how to factor the numerator? What's the numerator going to factor to? Alright, any idea? What's the greatest common factor each of those terms has? M. So M is one factor. If M is the greatest common factor, this other factor we can find by taking that and seeing what do we need to multiply M by to get the first term. So M times M to the first power times M to the second power gives us M to the third power. If this is a plus, this has to be a plus. What do we have to multiply M by to get 9M? We have to multiply that by 9, right? What's the greatest common factor of the denominator? 3M, right. So if the greatest common factor is 3M, what is the other factor? 2m minus m? That would be 3m squared, right? 3m times what would give you 3m? Yeah, there you go. So now we find our excluded values before we cancel anything. We have two factors that have variables in them. So we set the 3m equal to 0, and we set that 2m minus 1 equal to 0. Undo multiplying by dividing, so now we know that m is 0, can't be 0. So just two-step, we'll undo the subtracting by adding. Undo the multiplying by dividing. So we know our other excluded value would be 1/2. So now, m and m looks like it should cancel, but it can't, right? We can't cancel part of a factor. These are in these parentheses, they're a factor. Now this m and this m, we can cancel those. M divided by n is 1, right? So what we have left in the numerator is m squared plus 9. What we have left in the denominator is 3 times 2m minus 1. But we have to remember our excluded values. M cannot be 0 or 1/2. Any questions? Realize. Another example. Let me see what that. Okay. For this next example, let's go ahead and write in here that it's like number 14 on your homework. And you don't have to write that whole thing. You're going to write what I write. I'm going to draw a rectangle. And in that rectangle, we're going to say the area equals x squared plus 6x minus 16. And then we're going to say the width is equal to x minus 2. They're asking us to find the length of this rectangle. So the formula for the area of a rectangle is what? Anybody remember? What's the formula for the area of a rectangle? Length times width. If we know the area and we know the width, so let's say, for example purposes, and you don't have to write this down, let's say we had an example where the area was 24 and the width is 6. How can we find the length if we know the width is 6 and the area is 24? What's the operation we would use to find the length? Yes, we take the area and divide by the width. So that's what we're going to do here. We're going to take, for the length, is going to be equal to the area divided by the width. So our length is going to be equal to x squared plus 6x minus 16 divided by x minus 2. Any questions? Now we do all the same steps we just did. Factor the numerator. Well, this is a equals 1 here, so we're going to use our x. The product of our factors is going to be negative 16. The sum of our factors is going to be positive 6. I know one's going to be positive and one's going to be negative. And if I want a positive 6, then my 2 is negative, and my 8 is positive. Negative 2 times 8 is negative 16. Negative 2 plus 8 is positive 6. This is review, so I'm going through it kind of fast. So our numerator factors into x times x. That's how we get our x squared. Negative 2 means minus 2. Positive 8 means plus 8. Nothing to factor in our denominator. The only thing we can take out of that binomial would be a common factor in both terms, and there's not one except for 1. All right, now, before I cancel, just say what the length is, because we're still finding the length, we're going to find the excluded value. So we're going to exclude based on the denominator factor. So my excluded value is 2. Any questions so far? So the factor that's going to cancel, remember, this does not parentheses around it, but it's still one factor. So these and these cancel, so our length is x plus 8. So we have to say that x cannot be 2. Any questions? All right, and we are going to do this example. We've got time. So these are like problems 18 on your homework. So go ahead and write these directions. And you're going to write here that this is like 18. This is like 18 on your homework. Are the given factors opposites? And explain. So we're going to start by talking about what opposites are. Cold and hot are opposites. Up and down are opposites. Slow and fast are opposites. Short and tall are opposites. But in math, what is an opposite? What's the opposite of 5? Negative 5. What's the opposite of 100? What's the opposite of negative 20? So we can say that opposites have opposite signs in math, right? And that's what we're going to say. Another way to say that would be that one to the other. If you multiply it by negative 1, then you would get the other number. But we're just going to say opposites have opposite signs. Or let's say different signs, because there is only 2 signs, one positive and one negative. We're going to say same absolute value, actually. It's not just an opposite sign, because negative 10 and 5 are opposites, right? But they're the same absolute value and different signs. So we'll write for our example 10 and negative 10, and negative 20 and positive 20. If I divide 10 by, or multiply 10, divide or multiply 10 by negative 1, I get its opposite. If I multiply or divide negative 20 by negative 1, I get its opposite. That's another way to define it. So let's look at these. These have 2 terms. If an expression has more than one term, all the like terms would have to be opposite. So all the terms that have the same absolute value would have to be opposite. So 5x minus 2, 5x is positive and 2 is negative, right? You may want to reorder this. Now we're looking at 2 minus negative 5x. If I rearrange these terms, now I see that minus 5x is really negative 5x, and that's a positive 2. These are the same expression, except one is positive and one is negative. They are opposites. These are the same absolute value. They're the same expression, except one is negative and one is positive, right? Does that make sense? Does that make sense? Does that make sense, your boys? Make sense to you guys? So we're going to say yes, they are opposites. because each term are opposites. So now we're going to look at B. Negative t plus 10, positive t plus 10. Are negative t and t opposites? Yes. A positive and a positive 10 opposites? No. So in order for these two expressions to be opposite, all of those same terms, in terms of the same absolute value, have to be opposite. So we're going to say no here. Because 10 and 10 are not opposites. Or because both terms aren't opposites. However you're going to say. But I'm going to say because 10 and 10 are not opposites. Number 24 and number 6, you're going to have to split the middle term and use grouping. So number 24 and number 6 is going to be A times C. And then split that middle term and specify that grouping. And for 24 and 26 in your homework. Remember, you're not going to find the spots and scan to make your homework. You will find the spots and scan to make your notes. So you can go ahead and scan to make your notes